Okay, so now we're ready to start looking at and get started on Module 2, which is displacement analysis. So we have a learning plan. So Module 2 learning plan, if we click on that, you're going to notice that we have a PowerPoint presentation. Okay, and then there's also a little bit of a handout here, and then also a spreadsheet that we're going to be looking at to help us with an example and a practice, or I mean, an assigned problem. You're going to notice that we have a couple lectures here. We're going to be meeting today on Module 2, and then also on Wednesday. We should be finishing up at that point so that you would be ready to do the assigned problems for Module 2. You will be handing in practice problems for Module 2, which we're going to be actively working on today and during our lectures, and then assignment 2, like your application, if you would. If we go back that level, then you're going to notice that I will be populating our session recordings. So today's session will be found in the session recordings here, and then any other lectures that we do. You will notice that there are some from fall 2024. Okay. So again, if you are looking to work ahead, if you know you're not going to be here, something like that, those are always out there for you to reference if you need to. And like I said, sometimes you get done with the first lecture, like I cannot wait 2 days to learn about, you know, the next part of this chapter. You can always go to our go to our 2024, or I think I've mentioned this to you as well. If you're having a hard time sleeping at night, might just put you right to sleep. So it's happened. It's happened. But then we have our practice problems here. So our practice problems are going to be the ones that we're going to actively be doing while we are in class. So you'll notice that we have them identified from the chapter. Reminder, as we go through our chapter, I'll kind of in the learning plan, it'll say read chapter, blah, blah, blah. But remember, the PowerPoint presentation and anything that we go over, those are the sections that you're responsible for, because, and we do skip around, we kind of skip over some items. So just so you know, use that as your guide as well. So you're not, you know, doing more than you need to, if you would. And then you're going to notice here that we have some homework problems that we're going to be doing pertaining to the work that we're going to be doing here in Module 2. So I think we're ready to get started. So let's head over to our learning plan. And the first thing I'm going to do is I am going to pull up the PowerPoint presentation, which, as we know, is going to guide us through our chapter. So I'm just going to zoom out just a little bit. Now, the chapter we're going to be looking at here is chapter 4. So we started with chapter 1 in this book, and we're skipping over to 4. And the only reason I do that is I'm not crazy about the order in which they kind of identify things. So they introduce kinematic diagrams in chapter 1. And then in chapter 2, they introduce a different kind of a software to solve these problems. We don't have you guys get that. We just use AutoCAD for our layout work. And then in chapter 3, they start talking about vectors. And then they go to chapter 4, and then they kind of come back to this idea of diagrams and moving things around. I feel like I want to do the moving around now, because you guys are fresh in your mind. You've got, you know, diagrams and creating those kinematic diagrams. Now let's take it that logical to me. Next step is to kind of move things around and see how other things are positioned. Then next week in our next module, we're going to be looking at vectors. So I wanted to kind of give you a little bit more time here creating our diagrams before we shift gears and look at something else. So we're going to kind of skip over to chapter 3, or chapter 4, but we will be coming back to chapter 3. So our objectives here are to do the following. We want to define position and displacement of a point or a link. Okay. Determine the positions of all the links in a mechanism as the driver link is displaced. Okay. So we got practice doing diagrams of exactly how a mechanism was in that, if you would, like home position, like right here. Okay. Now we know that those mechanisms are going to move. Okay, well, let's move the driving link and see how that affects the other links and points that are in that mechanism. And then here, determine the position of all the links in a mechanism through an entire cycle. So an entire cycle is going to be, well, when we rotate, if you would, the crank 100 or 360 degrees all the way around, what does that do over here? Okay, on the rest of the items in the mechanism. We're also going to be doing something called limiting positions. Limiting positions are looking at, okay, if I have an input what are the furthest out or the closest positions, whether it's a angular displacement or if it's a linear displacement, what are the extents for which that output is going to go through? We call that limiting positions. And then we're also going to, at the very end, plot what we call a displacement diagram. And that's just going to be a graphical representation of how something moves relative to the angle that the crank is going to be moving as well. So lots of things that we get to do here in Module 2. So first of all, introduction here. The purpose of kinematic analysis, as we know, is to determine the location of all the links as a driving link of that mechanism is moved to another position now. So we looked at home position, if you would, or like frozen in time, draw a diagram like right here. Now we're going to take it from that right here to a new position, okay? Kinematic analysis can help us to determine, first of all, what is the full motion of our mechanism, okay? It helps us to identify, okay, as we move our driver, for instance, a crank around, what's happening to the rest of the mechanism when we have 2, 3, 4 other elements that are connected and affected by that motion. It also helps us to determine position of the different elements, whether it is the links and also the joints, like where are those located now as we've had some, motion going on. We can determine the extents or the range of motion, and we can also determine what those spatial requirements are. Many times when we're in that layout phase, which kinematics is, first phases of the design process, we want to make sure that we're not interfering with other elements that we have to, work within, okay, or around. So that's going to help us to identify that as well. So it's really, like I said, it's that layout work that we're going to be doing for our mechanism that we're designing. So now position. Position is going to be the position of a point on a mechanism is its spatial relationship or its location to or of that point, and usually relative to something else, okay? We usually, and a lot of times it's relative, for instance, to the frame, okay? Because that's not going to be moving. So it's understanding exactly where that's located, if you would, in space relative to something. The primary goal of position analysis is to determine the location of points on a mechanism relative to that driver or that crank rotating or moving, okay? Now, displacement is going to be the end product of motion, all right? So linear displacement is when we have straight line distance between the starting and the ending point. So when we have an element like a slider, it only moves in a linear motion, straight line motion. It can be horizontal, it can be vertical, it can be at an angle, okay? But linear displacement is, okay, where did I start? And now where did I end due to motion of an element, okay? So that's what displacement is. It's linear displacement. Angular displacement is gonna look at how many angles or how many degrees did I go through when I went from, if you would, a start position to an end position, okay? When we talk about linear displacement, many times that's referred to as stroke, okay? If you've worked in automotive applications, stroke is a very common term to kind of identify how far a cylinder moves, okay? Angular displacement is described as the throw, okay? So as we have a point that we rotate about, that total amount of angular displacement that it moves through, that's going to be what it was, the throw, okay? And then we have an angle that we say that happened, okay? That start or that ending angle. Now, we are going to be looking at the graphical solutions only for displacement, okay? So in our chapter, you're going to notice that there's going to be graphical solutions for these problems and then what we call analytical or the math solutions. You can run the math. You can do the sine and the cosine laws, use our trig functions. But you guys get to do that a lot in a lot of classes, okay? So here in kinematics, we are going to stick to just the graphical solutions, and that's really enough. I trust that you have, through physics, the math, as well as other courses that you've had here, statics, strength of material, machine elements coming up, you've got a handle on this. And if you want to practice and explore that, there are examples here you can go through on your own. but we're just not going to have you guys responsible for that. We're focusing just on the graphical analysis. Okay. Just so that you know, if a problem that you're assigned asks you to analytically solve, graphically always solve. Okay. Because we're not doing any analytical work in here. Okay. Graphical is enough. And especially in an 8-week format, this is perfect for what we're going to be doing. So the graphical analysis, basically, we want to determine the position of all the links of a mechanism as the driving link moves, okay, as the driving link moves. So the process we go through is, first of all, we're going to draw that kinematic diagram in whatever its home position is, okay? So for instance, in the examples that we do, we're just going to draw it as is, as it's shown, okay? Then what we're going to do is we're going to confirm and calculate degrees of freedom, okay? So we want to make sure that if we have an idea of how many degrees of freedom there should be, a lot of times it's 1, but we know that it can be more than 1 as well. We just want to make sure, especially when we know something's not moving, or when we know something is moving, that we don't end up with a 0 or a negative value. Then that really kind of checks to make sure that we have the right amount of links and joints that are present, okay? Then number 3 here, step number 3 is going to be, then we're going to move that driving link to its new position, okay? And then we're going to displace what we call the remaining slave links, the ones that are dependent on the motion of that particular driver. So if we look at page 74, I don't think I have an illustration of it. So if I look at page 74 here, I'm going to look at figure 4.5, okay? Figure 4.5. Now, figure 4.5, what we have is, you'll notice in the solid, if you would, object line of our mechanism, we have identified here first our frame, and then connected to the frame is link number 2. 3 is connected to 2, which then connects to 4, which then is back to the frame. Now, this is a classic 4-bar mechanism, okay? So as we look here, typically how we're going to number, and you've kind of noticed me doing this in module 1 already, but we typically number our mechanism so that obviously number 1 is always going to be the frame. That's not negotiable. That's always the frame. Number 2, though, is going to be our driving link, or what we call a lot of times referred to as the crank or the driver, okay? If we have this as number 2, we're expecting that this is going to be our driving link, the one that is controlling the motion of this mechanism, okay? And then the slave links then are going to be the ones that are going to, if you would, react to that driver. So if number 2 is our driver, then that means it's going to affect how link number 3 and link number 4 are going to move relative to its motion that it has. Now, in this case, you're going to notice that the dark lines show our initial, if you would, home position of this mechanism. What the book then did was it moved that driving link number 2 15 degrees clockwise, okay? Notice the new position they show in, if you would, a dashed or a hidden line sense here to show like the new placement of, okay? Now, what you would continue to do, and they really don't show us this, but you would continue to then add on the next links to show how they would change their position, okay? So we would move this first, and then, oh, let me see. They do have it, good. Then if we go over to the following page, 4.9, you're going to notice that then they're going to kind of strike the path for the other elements on how they are going to move. And then as we turn the page one more time, then the final result would be connecting the new positions for the elements. That's what we're going to be practicing here in module 2. We're going to be first drawing in, if you would, the home position, our kinematic diagram. Then we're going to be moving the crank, for instance, to a new position, and then showing how the other elements are displaced. It might be a slider, it might be a rotating link or an oscillating link, but then we'll be able to then identify how those links change, okay? Let me go back over here. Now, the first example we're going to look at is going to be example 4.1. Okay, example 4.1. Example 4.1 is found on page 76 in our book. And the process that we're going to go through is going to be like these 6 steps, basically. So we're first going to draw the kinematic diagram in its home position as we see it, okay, in the example. Then we're going to move the driver to a desired new position as identified in the problem statement, okay? Then we're going to use CAD to construct the new positions of the other links. And then we're going to draw the new positions of the links at the intersections that we determine, okay? So in this example problem, we're going to walk through. We are going to use AutoCAD. This is going to be your first practice problem that you'll be handing in. So if you want, go ahead and go to AutoCAD and pull up your kinematic start file, because then we'll use those elements in this particular example as we walk through. And on page 76 is example 4.1. So I'll give you a chance to open up AutoCAD and get your start file going. And then we are going to be walking through the process of example problem 4.1. Right. It looks like most of us are here. So let's take a peek at our example problem to see exactly what we're supposed to do. And then we'll kind of, look at the illustrations that they have here. So it says here, figure 4.11, which is at the bottom of this page, shows a kinematic diagram of a mechanism that is driven by moving link number 2. Okay, so if we look down here, this is the mechanism that we have. And they have link number 1 as our frame, and then connected here on the left-hand side, this is link number 2. So they're telling us that link number 2 is the driver, okay? And truly, then what that means is as we rotate link number 2, then we want to find out, what they want us to do is find out what is the displacement of the other links that we have here, okay? So if we look, graphically reposition the links in the mechanism, if when link 2 is displaced 30 degrees counterclockwise, okay? Determine the resulting angle displacement of link 4 and the linear displacement of point E, okay? So if we look down here, link 4 is right here. So they want to know from this position, as we move link 2, was it 30 degrees counterclockwise? So we're going to rotate this, if you would, to the left 30 degrees. What happens here to, or what's the displacement of link number 4? Because it can only rotate about a point, that's going to be an angular displacement, okay? And then they also want they want to know what is the linear displacement of point E. Point E, you'll notice, is on the slider. So if this is being pulled counterclockwise or shifted to the left, this is also probably going to shift to the left, right? Which we're expecting this then to pull to the left. And they want to know from this position to the new position, what is that value? All right. So that's the process we're going to go through. So number 1, we're going to draw the kinematic diagram as we see it right here. Okay. And then we're going to do the rotating. So first things first, we don't have to try to determine what the kinematic diagram is. We're just going to duplicate exactly what we see here, okay? And that's what's on here. Now, because we're going to be interested in actual values, angles, and distances, you're going to notice now we're going to start getting actual dimensions, okay? So we're going to have to now draw things to scale, okay? So it's not going to be like in module 1, we're like, just make it proportional to kind of get the idea. Now we have to actually make them to the distances, because in your assignments, you're going to be getting the final answers. If you don't obtain those final answers, then somewhere along the way there, something might not have gotten drawn quite right. And that'll be your first thing to check, actually. Okay. So let's go ahead and create the diagram that we have here in AutoCAD. So I have my AutoCAD up. Hopefully you do too. And we are going to have two positions that we're going to need our frame. So I'm going to do a copy, which is right below move. I'm going to arrow around my frame, and I'm going to copy, I don't know, over here-ish somewhere, okay? And then I am going to move this copy kind of up, turn my ortho off for right now, up and to the right. So the one on the left is going to be my point A, and the one on the right is going to be point D. So if we look back at our, see, I did the wrong one here. If we look back at our diagram, I want to place my frame for A and my frame for point D, okay? Now, you're going to notice that they're giving us actual dimensions, okay? 5.3 to the right of A is D, and then 3.2 up. Now, to do that, we just simply have to just kind of construct the lines to find that intersection. So I am going to change my layer. I'm not going to do the object line layer. I'm going to do the 0 layer, okay? Just because then I'm going to just delete those when I'm done because I'm not going to really need those. So I'm going to draw a line through the center of my frame member. So I've got to find the center here. Make sure you grab that center. And I'm going to make a horizontal line, okay? Just a random distance, okay? And then I'm going to do a vertical line through that same point, okay? I don't know, random distance. So now all I want to do is I want to offset to the right 5.3 inches. So I'm going to do the offset command, which is right here, underneath our eraser. And I'm going to offset that 5.3. So I'm going to go from here to here, okay? And then I'm going to do it again, offset. You can hit enter to redo that same command, but this time my offset is going to be 3.2. I'm going to select the bottom line and go up. So the intersection right here is going to be the location of my second frame member. So now I'm going to move my second frame member from its center to the intersection right there. Yes.
So the way I would have initially thought was just doing like an L shape of 5.3.
You could do that too if you want. Yep. Yeah, there's multiple ways to do this, right? You can use the offsets, but you need to some way construct that location. So yeah, whether you draw a line over to the left and up to the right, that's actually a good way to do it. I don't know why I didn't even think of that, but that's, yeah, there's multiple ways that we can get that point. So whether it's using offsets or drawing the lines over, actually I like that better. Yeah, no, you didn't do anything wrong. So it's just really locating relative to that. Okay, so now we have those there. So then I'm just simply going to erase those construction lines that I just created. Okay, so those are my positions. The other thing I am going to do right away is I'm going to move my A to that position so that I know that my A is identified there. And I have now placed, this is going to be D. And we're going to use the same letters that they used in the book. So A is the bottom left frame, and it's the pin connection there. And D is going to be the upper right frame pin connection there. I can also at this time move my frame member, my frame identifier number 1, and I'm just going to put that by the lower left one. Okay. So now I have those two in position. If I go back to my illustration, my first link is link 2, right? Connected to the frame here. That is going to be 3 inches, and it's 90 degrees or a vertical to that link. So I'm going to go back to AutoCAD. I'm going to go back to my object line layer, and I'm simply going to draw a line from the center straight up, and here I can key in 3. Okay, and make sure you are vertical. If you have to put on your ortho again, do that, or along those snapping lines. Okay. So that's 3 inches long. Okay. Now what I want to do is I am going to locate point C. Okay. Now I know that that C can only travel along a radius here. Its center is fixed at point D. Okay. And its radius is this 3.3. So it can only travel along that, right? So I'm going to draw first. And I'm going to go back to my 0 layer line. I'm going to kind of use that as my construction line layer, if you would. And I'm going to draw a circle center radius. Okay. And the center is going to be at the center of point D, that second frame member. And its radius is going to be 3.3 inches. Okay. So that's going to be the radius. So the distance from the center out is 3.3. So somewhere along that circle is going to be that endpoint. Now, if we look back to construct that, I'm now going to go from the endpoint of B, and I'm going to draw another center radius circle, and I'm going to do that radius 4.9. And where that intersects is going to be where point C is. Do you see that? So if I go back over here, I do a circle center radius again, and I'm going to have my start point, or my center point is going to be the end point of link number 2. And then my radius is going to be 4.9. Okay. All right. Now, where these two intersect is going to be where my point C is. Now, notice it intersects in 2 spots. All right. But the position that we're seeing here in this illustration is the one that's on the upper side. Okay, so C is going to be up there. So now I'm going to go back to AutoCAD. I'm going to go to my object line layer, and I'm going to draw in my line from the endpoint of that link to the intersection of those 2 circles that I have. Okay, and then I'm going to grab one more line from that intersection or endpoint to the center of point D. And that is going to be then that link. Okay. Everybody have that so far? So this kind of gives us a way of constructing, if you would, especially when we don't know exactly what angle it's at, but we know the distance is, okay, like the radius is. Okay, so then what I'm going to do now is I'm going to move the designation for link number 3 to be like here-ish. And then I'm going to move the designation for link number 4 to be there. Okay. So I've got, oh, and then I can move 2 to be, I'm going to put it on this side. There we go. There. Okay. I'll add my points in just a little bit, my other points B and C, until we get some other things in place here. I find that catching endpoints is easier than always having to shift right mouse button to do centers when I put my joints in place. Okay, so now we've got the first 4 links on this mechanism. Let's go back underneath. And now we need to add in our next link and the slider. Okay, now we know that the radius of link number 5, okay, is going to be 10.1 inches. And it's going to connect to a slider that is 0.8 inches up from distance D. Okay, so, or I should say point D. So we're going to go back over here, back to AutoCAD, and I'm going to go back to my 0 layer line, or 0 layer, and I'm going to construct a horizontal line. So I'm going to put my ortho on, and it's going to come from the center of point D here, and I'm just going to make a horizontal line randomly out there. Okay, and then I'm going to offset that line 0.8 inches. 0.8 up, okay? So on that line that I just offset is where my slider is going to be. So I'm going to move my slider, I'm going to window around it, and then from the center, I'm going to just put this, turn my ortho off, I'm going to put it nearest along that line, somewhere along that line. So make sure you're nearest or something like that, okay? So I'm just going to put it on there. Now, I'm going to get rid of the bottom horizontal line, but I'm going to leave the line going through the center of that slider. And the reason I'm leaving that is because that line is going to represent the line of action for which that slider can move on, okay? 0.8 up from D. Now, where it's going to be located is I'm going to draw another circle center radius, and I'm going to make that a radius of 10.1, and where it intersects with my line of action is where my slider is going to land then in this position. So I'm going to go back to AutoCAD. I'm on the 0 layer, so I'm going to do my circle center radius. So from point C here, from this endpoint right here, I'm now going to draw another circle, but this radius is going to be 10.1 inches in radius. Look at that. It's pretty darn close. And now I'm going to position my slider so that its pin connection is at that intersection that I just created with that radius and the line of action. So I'm going to do a move, and I'm going to go, my base position is going to be from, not endpoint, sorry, it's from the center. Is it going to grab it for me? There we go. To the intersection that I just created. Okay. And then now what I can do is I can change my layer back to object, and I'm going to connect from what would be point C, which I'll label in just a little bit, to the center of my slider. Okay. Now, I haven't done this. It's really something I usually try to do right away. But if you haven't done this, we're going to do a file, save as, and we're going to call this not kinematic start file because we don't want to go over the top of that, but we're going to call it example. And this is 4_1. There we go. Okay. All right. Now, as a really quick check, what I'm going to do is I'm simply going to erase the lines that I used for construction, okay? And all I'm going to do is I'm going to do what we call aligned dimensions. I want to make sure that all of my dimensions along my radiuses are good. So aligned dimensions. So if you need to arrow down and underneath linear, there's a line here. And these are just a check. This isn't anything I'm going to keep on here. So right now I have 10.1. That confirms that distance. I'm going to check the next one, and I'm going to get rid of these in just a little bit, but it just confirms that all of my distances are correct, 4.9, because I don't want to get all the way done. And then all of a sudden I'm like, oh crap, that one dimension wasn't quite right. Go to the end point. There we go. Okay. So I've got 3, 4.9, 3.3, and 10.1. Okay. So I'm not going to do the other dimensions because I'm pretty confident in those, but that looks good to me. So then I'm just going to go back and I'm just going to delete these dimensions because I'm not going to leave these on my diagram. I just wanted them there for verification. Okay. Now, once I have those and I'm confident in what things look at, like then what I want to do is I want to move my letter B to where it is at the end of link number 2, and I'm going to move C to the end of link number 4. And then what I need to do is add my labels for the last items because we've got a couple extra links and joints. So I'm going to copy my link 4 to what's going to be 5 and then to the slider. Okay. And I'm going to change this one to 5, which is a long link number 5. And then the slider is going to be link number 6. Okay. And then I'm going to copy, you can copy whichever letter you want. So I'm going to copy D to be the center point of my slider. And then another, what's going to be the last one. So this is going to be point E, I believe, right? Yep, E is going to be at the slider. And then I have F is going to be the joint at the slider to the surface that it's constrained by. Okay, so add those couple last layers, and now we have our links and our joints identified. So the links are whether they're just a straight link like we see here for each one, or a slider. We label those with the numbers with the circles, and then the joints, in this case, the pin joints, as well as the one sliding joint would then be the letters. Now, before I move on to the next step here, I am now going to add in my pin designation. So I know that I'm going to copy this pin connection, and I'm going to go from its center, and I'm going to copy it to the endpoint where C is and the endpoint where B is. Otherwise, all the other ones have the pin connection call out. And then I'm going to do one quick file save for my example. So now I have this in, if you would, the home position, the start position for the illustration that we have here in this example. Okay, any questions? Right. Okay, so once we have our diagram in place, the next thing we want to do is just confirm or calculate the degrees of freedom. Okay, so to do that, I'm actually going to go underneath my camera and I'm going to do it manually. Now, just like we did in Module 1, you have a couple options for the calculations for mobility. You will continue to do those for each one of the diagrams that you create. So once you have the diagram created, the kinematic diagram created, always do the mobility or the degrees of freedom. You can either add it to the CAD file here. You're welcome to do that as a note. Or you can put it as part of your document that you put the screenshots to, or you can do it by a hand calculation and then just take a picture of that and scan that in. So you can choose from whichever one that you feel comfortable with. So what I'm going to do is I'm going to handwrite mine. So I'm going to go underneath here. So this is example problem 4.1. Okay, and this is going to be the mobility equation. Now, before you put any numbers in, you always have to show the equation in variable form. So the variable form of the equation is F is equal to, remember that's degrees of freedom, 3 times n minus 1 minus 2 times JP. Your n is going to be the number of links in the mechanism, and your JP is going to be your primary joints, which are the pins and the sliding joints. Okay. All right. So now we're going to say, all right, F is equal to 3 times. We have to look to our number of links. So we go back to our kinematic diagram and we look at, okay, what was the highest number that we put a circle around? And that was 6, right? Okay. So over here on the right-hand side by our slider, that's link number 6. So I'm going to go back underneath here. So that our n is going to be equal to 6 minus 1 minus 2 times primary joints. Okay. So I'm going to go back underneath AutoCAD, and I have joint A, B, that's 2, C is 3, D is 4, E is 5, and then don't forget F. That's 6. Okay. So it's 2 times 6. Okay. So our F is going to be equal to, so if we look here in the parentheses is going to be 5 times 3. So that's going to be 15 minus 12. Our F is equal to 3. And you might be like, wait a second. Okay. Well, a couple of things. When we look here at this mechanism, if you recall, when we drew the circle for the radius of link number 3, it connected with the radius of link number 4 in 2 places. All right. So there's 2 actually different places that those could connect at the position that this is at. So that means that those links need some extra help, like to know where they are. So they're going to be needing some help positioning themselves. So we have 3 of those. So link number 2 link number 3, and link number 4 are going to have to be manually placed, if you would, some way, somehow in your mechanism. I don't know what this mechanism is being used for. We're just going along with what they have. Again, I don't want you to think that, oh, because it's 3, that's bad. No, it's just that's how that mechanism works. We have mechanisms that need more than 1 degree of freedom or more than one thing to do to get it to its final, state or function. And that's okay. 1 is ideal, but that doesn't mean 2, 3, 4 is not okay. All right. Does that make sense to everybody? So our F is 3 for this particular. So whether you put that again as part of the AutoCAD file, part of the document, or hand write it, just make sure that you include that one way or some way somehow. Now what we're going to do is I'm going to go back underneath here. We've got our mechanism all set. If we go up to the top of page 77, we are now going to position link number 2, which is considered our driver, an amount of 30 degrees counterclockwise. So we're going to rotate it back. Okay, we're going to rotate it back. So let's go back to AutoCAD and do that. Okay. Now I'm going to add a new layer here. I'm going to go to my layer properties. You're going to notice that when the book moves to a new position, they will change to a different line type, okay? And typically that line type is either, in their case, in some cases, it's going to be a little bit lighter as far as the line weight. But for us, we're using AutoCAD. Why not just change it to a different line type? So I'm going to do a new layer. So I'm going to select on object. It's still going to be an object line. And I'm going to call it object 2. You could call object 1, but I'm just going to call it object 2. I'm going to change the color to green, just the standard color green. And then I'm going to change the line type from continuous. I'm going to load the hidden. Okay, so it's really going to be a hidden line, if you would. But we're just using it for a new position. Make sure once you select that and load that hidden line, that you then reselect it to be the line that we use and that it changes to hidden for the line type. So the only thing we're changing here from object to object 1 or object 2, whatever you want to call it, is going to be, it's green and it's a hidden line type. The line weight remains the same. Okay. All right. And then now what we're going to do is we are going to rotate copy link number 2. Link number 2 is our driver. So we're going to do the rotate command. Now we've got to watch our command line. Okay. So it's going to ask us right now, select what you want to rotate. So I'm going to select just link number 2. Okay. I'm not going to add the pin connection because, again, when I do everything, I like doing the pins last. So I'm going to select that. I'm going to hit enter. I only want that one thing. Select the base position. The base position is going to be where it's fixed to rotate around, which is going to be point A. So I'm going to shift, right mouse button, center, and this is where I'm going to rotate. Now, before you click or you put an angle in, on our command line, it wants to know, do you want to copy this? Yes, we want to leave the original copy behind, and we want to then rotate a copy that we create. So we're going to say C, enter. And now notice it leaves behind a copy. I haven't clicked yet. I'm just moving here. And now I'm going to enter in my rotation angle. In AutoCAD, anything going counterclockwise is a negative rotation. Anything going clockwise, no, I'm saying that wrong. Anything going counterclockwise is positive. Clockwise is negative. So we're going to put in 30 degrees, no negative. So 30, enter. And now you're going to notice that its new position is counterclockwise from the original one. I'm now going to select on it, and I'm going to change its layer to object 2, and then hit escape. And I'm going to leave that there. Okay, so that's my new position for my crank or my driver. Okay. If you wanted to confirm, you could put that angle in there. I'm pretty confident, but I'll put an angular dimension in. I'm going to arrow down. Here's my angle dimension just to prove that I've got 30 degrees. And I do. I'm just going to hit escape. just select the line, just left click it. And then you're going to go up to the layer and then just change it to whatever layer you want it on. Yep. Any other questions? All right, so now this is the new position, the new endpoint, if you would. So B, I'm gonna copy B over. Okay, I'm gonna take B and I'm gonna put it at the endpoint of my new line. Okay. Usually we don't move the link designations, only the new points. Okay. And now because it's a new position, we're going to double click on that and we're going to add what we call a prime. Okay. So, or it's an apostrophe. So it's B apostrophe, B prime. That means that this is the new position from the original. The originals don't have primes. The new position has a prime. Okay. You're going to notice that's what the book does. And then if there would be a second position, it'll be a prime prime. Okay. And which happens at times. All right. So now that's where link number 2 and our new point B prime is. Now what I want to do is I want to locate where C is. We're going to do the very same thing that we did the first time. For construction purposes, I'm going to use my 0 layer. I'm going to go to my circle center radius. And I know that the radius of C here, I'm going to shift right mouse button, it rotates about point D, fixed point D, right? So make sure you get that center. And you could either go to the endpoint here, or you could key in the 3.3. Enter. There we go. So remember that link 4 is only going to rotate along that path because it has a fixed center at D. And then we also know that the length of link number 3 is 4.9 inches long. So from the endpoint of B, which is going to be the center of our circle center radius, center here, its radius is going to be 4.9. Enter. Okay. Now, I'm going to have to zoom in. There is an intersection here of those two lines. That's where I want to go. So now I'm going to switch back to my object 1, the green layer. I'm going to do a line from the endpoint of B prime. And now don't catch up here, catch the intersection of the two radiuses. Okay. And then from there, I can go right to the center of point D. There we go. Okay. So this is my new, and I'm going to move my 3 with a circle. I'm going to put it on this side. Okay. And then I'm going to move my designation for C. I'm going to copy C. And its new name is going to be C prime. Okay. Because it's now the new position of C. Doesn't hurt to do a quick save. Okay, any questions so far? I'm going to get rid of these 2 circles. So I'm just going to simply delete those because I don't need them anymore. Okay, and then my construction now is going to be for the last 2 elements. Now, the last 2 elements, my slider, I know it can only move horizontally. Should have left it where that one line in, but I didn't. I deleted them all. So I'm going to go back on my 0 line or my 0 layer. I'm going to create a line and I'm going to start at the center of point E, right? The center. Did it get there? Yeah, the center. And I'm going to draw a horizontal line. So make sure you have ortho on. And I know that this is going to pull back only to the left of where it's at. So I'm just going to draw a horizontal line to the left. Okay. That's its line of action. Now, as we look at link number 5 here, we know that link number 5 is 10.1 inches long and it connects to C prime, right? So now I'm going to do another circle center radius and I'm going to find, make sure you get to the end point of C prime and its radius, I need to turn off my ortho, its radius is going to be 10.1. Okay. And now the new position of our slider is going to be at the intersection we see here. Do you see that? Okay, so now I'm going to do another copy. And I'm going to window around. Enter, and then I'm going to go from my endpoint here to the intersection there. Okay. What I am going to do is probably I'm going to have to fix up my my hatching, but that'll be in a little bit. How did that do that? Oh, I know. Now we need to select the new items and we need to put those on the object 2 or 1 layer, however you identified that. Okay. And then I'm going to get rid of at least one of these and I'll probably make a new box for my hatching just because they overlap. If they were further apart, it wouldn't be a big deal. We need to create a little rectangle down here and we'll just create 1 rectangle. Okay. And then we're going to hatch on the inside. Hatch. There we go. And C31. And we're just going to put it right there. Okay. And we'll hit OK. And then we can get rid of that outside box so that we just see the hatching. There we go. Does that make sense to everybody? And then the other thing we need to do is move our F. Okay, I'm going to move it to this side. Okay, and that's going to be called F prime. So you put the prime in back of F. And then our E is also going to copy over. And that's going to be E prime. Remember, our links we don't copy over, okay? Because they're kind of, I think they're kind of obvious, if you would. Now, lastly, we need to put link number 5 in place. So link number 5 is going to go from C prime to E prime. So I'm going to change back to my object 1 layer, line, got to go from that endpoint to the center of that circle. There we go. And I'll have to move my F prime. Oops. Down here. There we go. So this is kind of the new area that we just created. I'm going to get rid of my circle. I don't need that anymore for the new position. Any questions at the moment? Okay. Now, what I'm going to do is I'm going to add back in. I just need to put the 2 pin connections at C prime and at B prime. So I'm going to just copy the one at B here. I'm going to put it there. And then I'm going to add it to the intersection at C prime. So now I've got all my pin connections. Again, I like to do those last. I think it's easier to add lines without having to do the center. Okay. So now we have the new position after we've moved that crank 30 degrees. So we're going to change our layer to notes or dimensions, whichever one, probably dimensions makes sense since we have that in there. And then I'm going to do first my angle dimension for moving crank 2 or my driver link 2. So I'm going to arrow down underneath dimensions here. It's linear at the top. I'm going to go to angular. Okay. It's this little down arrow. And then I'm going to click on those 2 lines, and in the middle, I'm going to move that 30 degrees. So that just lets me know, yep, you moved that 30 degrees. Then part of the problem, it wants to know how far link number, or what was the angle that link number 4 moved. Okay. I think that's what it says. Displacement of link number 4. So the angular displacement of link number 4. So it's going to be another angle dimension. So angle. Okay. And that is, I'm going to kind of pull it out a little ways. That is 26 degrees. Okay. Now, you would not put a linear dimension from C to C prime. This link is fixed at its center and it rotates around 360 degrees or oscillates. I don't exactly know until we put this through its full motion, but it's only going to be on that line. So this is not a linear displacement. This is an angular displacement because that link has a fixed center that it rotates around. Does that make sense to everybody? Okay. And then they wanted to know what was the displacement of the slider. Okay. Now the slider is a linear displacement because it's along that line. So we're going to do a linear dimension this time. And we're going to go from the center of E to the center of E prime. And our number is 0.9544. Okay. So this is, if you would, answering the question. Did everybody get all those dimensions? Same thing? Okay. When you get the right final answer, you know that you set everything up in the problem correctly. Okay. I know you got to wait till the end if you would, but be really careful and precise as you're putting the elements in place, whether it's, you know, the radiuses and such. So if we take a peek at what the book has for the answer, okay, you'll notice that they show, this is really just showing the construction, which we did, you know, in AutoCAD. And then their final answer is kind of a screenshot, if you would, of AutoCAD, all right? And you'll notice that the final answer here, the displacement of that slider is 0.9544, which is exactly what we got, okay? 26 degrees on link number 4, and then 26 degrees on link number 2. Notice they didn't put their link values in there. They should have, but we did it the right way. So make sure that you follow along with what I did. So, so any questions? All right. I'm going to get rid of any elements that you didn't need. Rainer, you had a question? Oh, okay. That's right. So now what you want to do is you just want to take a screenshot and then you're going to be handing this in as part of your practice problems. Garrett, you had a question.
Yeah, do we need to add that green dotted line layer to our spectral?
You could add it to your start file if you wanted to. Yeah, because you're going to start doing that now. Absolutely. You definitely could. Yep. Good question. So Garrett was just wondering, do you want to add that green layer, you know, to your start file? You absolutely could. Okay. So the next time we open it up, maybe we'll do exactly that. It's a great idea. That way you don't have to mess around with it later. Any other questions? Okay. So screenshot of this. If you do add your mobility calculation here, you certainly may. And then what you're going to do is you're going to open up a Word document. And this is going to be your first, you don't have to worry about putting like module 2 practice problems because you're putting it in that assignment. So you don't have to worry about that. But I do need to know that this is example 4.1. And then I don't think I took my screenshot yet. So Windows Shift S or however you get yours. And then you're just going to drop that in. Make sure you get all the information that you need. Control V. And then, like I said here, if you wanted to, you could add the calculation right here on the document for the degrees of freedom. Or I did mine by hand. You could take a picture of your hand calculations and then upload it as a screenshot here as well. So I'll let you decide how you want to do that, but make sure you add, I'll put add mobility calculation. Okay. All right. And then we would be ready for our next one. So any questions here? Okay. So it's the start of, so you're going to want to save that as module 2. Mod 2 practice props. And then we'll continue to add to this. Okay. All right. I am going to stop our recording at this time because then our next example, I'll start a new recording so that it's not quite as long.